One thing we could improve are the transitions of the links in our tree visualization. So if we click on morph, the links are appearing quite quickly, and it would look a little bit better if they would grow and shrink when we morph our visualization. We could do this by using a trick with the stroke, and let's explore this trick by using Chrome's inspector so we understand how it works exactly. First, let's try to get one line in our visualization, and we have this line 1 here, and we can see that our coordinates of the y coordinates are 320 and 480. So if we subtract those two, we can compute that the length of our line is 160, which is also the value you see when I hover above this line. So keep that in mind. And now let's learn about two SVG properties. And the first one is the stroke dash array. And with the stroke dash array, we can create a dashed stroke. So if we use 10, for instance, then you can see that we have 10 pixels of no stroke, 10 pixels of stroke, and then 10 pixels of stroke again. We can even create patterns if we want to. So now we have 5 pixels of no stroke, 10 pixels of stroke, and 5 pixels of no stroke. Another attribute that we can use on strokes is the stroke dash offset. And with the dash offset, we can move where exactly our stroke is dashed and where it starts and where it ends. And if we combine those two attributes, we can create the effect as if our stroke is actually getting larger or smaller. So if we use a stroke dash array of 160, which is the same as the length of our stroke, and we use a stroke offset of 160, our stroke becomes invisible. But if we start to get approach to 0 with our stroke, then we see that we create an animation where the line is actually growing. Now let's use our old trick with the transition in order to transition automatically. So let's just transition on everything, and maybe let's increase the time so we can see it a bit better for 5 seconds. And now let's go from 160 to 0. And now within 5 seconds, our stroke is starting to grow until it reaches the former point. So we could use this trick in order to animate all the strokes, but we have one more little problem to solve. And their problem is that not all of our lines are just as straight as this one. So for instance, we need to calculate the length of this line, which is where we cannot simply subtract the y coordinates. But what we could do is use a little bit of math, and maybe you learned the Pythagorean theorem in school. So let's quickly recap. It basically states a squared plus b squared is c squared. And what does that mean? So this is actually a law about triangles with a right angle. And we can create such a triangle if we take a look at this line, for instance. And yeah, let's just redraw this line. And let's say that this is our line C. And now we can construct our triangle by adding 2 more lines, which are A and B. And what we actually know about line C from our coordinates of the lines are the x1 and y1 and x2 and y1 coordinates. So we know x1, y1 and x2, y2. And if we use our knowledge about x1 and x2, we can calculate b by subtracting those two. And we can do the same for A if we subtract y2 and y1. And if we have A and if we have B, we can compute the length of C. So in order to do so, we want to have C and not C squared. So let's take the square root of everything. So we do math.squared of A squared plus B squared. And this is C. So now let's just translate the things we learned into a function, which we call line length. And we receive the parameters x1, y1, x2, y2. And now we can just copy over our ideas. So line A is x1 minus, or line A in this example is y1 minus y2, and line B is x1 minus x2. The order is not that important in that case because we are squaring those numbers anyway, so it's not important if they have a negative length here or not. And then we can say math.squared is a squared plus b squared. And this should allow us to compute the length of our function. So let's try that. And what we want to do is to add a stroke dash array, which is the same amount as our line length, y1, x2, y2. Forgot the comma. Now let's take a look in our visualization. Everything still looks the same, which is good so far. So let's see, this one has a stroke dash array of 160, which is what we expected. Now let's add the stroke offset, and now hopefully all of our lines will disappear. Or not. Let's see what we did wrong. Stroke, oh, it's stroke dash offset. Okay, now all the lines are gone. And yeah, we also need to change our transition. So let's also adjust this to 3 seconds. And now we need to change this dash offset depending on our toggle, as we did with the opacity. So if we are in the tree visualization, we want to have an offset of 0, so we can see the lines. And if we approach to the pack width, we want to have a line and offset of the actual length of our line. And if we try that, and we morph our visualization, you can see that the lines are getting bigger and shorter as soon as I start to morph. Maybe one thing which we could do in order to make the links a little bit nicer for the eyes is to use a dark gray instead of an black. And yeah, let's also try to another transition length. Maybe it looks a bit better if we go for 2 seconds. Yeah, I think it looks a bit better if the transition is faster than the rest of the transition. Yeah, and with these tricks with stroke dash array and stroke dash offset, we can grow and shrink any lines.